Okay, everybody, let's do some more videos to help you out. One of your recent assignments on Khan Academy was this assignment, calculating the test statistic and a t-test for a mean. Now remember, we always do a t-test, not a z-test, and there's two main conditions. One I want to emphasize more now than the other. The first one I try to drill in your head is when you fail CLT. When you're doing a sample that's too small, less than 30, right? You have to basically compensate. You can't do a Z, in other words, you do a T because of that. But there's one actually more critical. And it's basically this. Whenever you're using the sample standard deviation, which, by the way, if you think about it, that's what you're going to do probably 95% of the time, right? Whenever you're using the standard deviation of the sample. In other words, you don't know the standard deviation of the whole population. That's another reason why you do a t-test. And even though it's not covered in this video, don't forget I showed you how to do a normal plot, how to do a box plot and make sure it looks symmetric. And you definitely want to do that, especially on the AP exam, but we'll get more to that later. Let's get to this video here first. So, we are told that this factory fills these bottles with a beverage. Each bottle is supposed to have 500 milliliters. Now, using common sense, you want your machine to consistently fill it at 500. If it fills it a little less, of course, your customers may start getting upset when they have bottles that are not completely full. And obviously, you don't want to overfill it because then you're wasting beverage. So anyways, Nora is in charge of quality control. In other words, Nora is going to test these bottles, randomly select some bottles, make sure they're all within a certain 500 milliliter parameter. Okay? And she takes a random sample of 16 bottles and finds a mean of 497 milliliters with a standard deviation of 6 milliliters. Let's calculate the test statistic. In other words, we're going to assume that 500 is working just fine. The mean should be 500, but is 497 here that significantly different? Well, here is the calculation. Basically, remember when we did a z-score, we always took our score, compared it to our mean, and divided by standard deviation, right? Well, the t-statistic is very similar. We're going to take our score. We're going to compare it with basically, well, in this case, it'll be our x bar, right? And we're going to compare it with what we expect the mean should be and divide by our standard deviation. But now we're using a sample standard deviation. And when we do that, we have to divide by the square root of m when we're sampling. So, very similar formula. So, in our case, we're going to take 497. That was our x bar. We're going to minus the 500. That was our assumed mu. Remember, h naught would have been, mu is actually 500 milliliters. Okay? And we compare that to see what the difference is. We're going to divide, in this case, by our standard deviation 6 divided by the square root of 16. And as you can see here, I did 497 minus 500. I took this result, which is that answer right there, right? And I divided by, notice guys, I use parentheses. So if you want to do all of this together, you got to keep it together with the parentheses, or you're going to get a really screwed up answer. But anyways, long story short, our t-statistic is -2, so we would say t equals -2, and we would get it right. All right, let's do at least one more here. A company advertises that its cans of caviar contain 100 grams of the product. A consumer advocacy group doubts this claim. They obtain a random sample of 8 cans, and they find to see, and they're suspecting it's going to be lower, right? In other words, they're cheating on how much caviar is given in the container. But anyways, in the can. So their mean weight was 99 grams, which is pretty close, and a sample standard deviation of 0.9 grams for that sample. Notice that this is our sample standard deviation. This is the average, or X bar, okay, for our sample. So long story short, our T is going to be what we got, 99. We're going to compare it to what we assume it should be, which is 100. We're going to divide that by our standard deviation, divided by the square root of 8. And if we look, it looks like the correct answer is D. Notice C is there to trick us. They have the numbers backwards. Remember, it's always what you have, or what you're from the sample. You're comparing it to the mean, right? So don't get that backwards. We want this, not that. Let's do one more. Fernanda runs a large bowling league. She suspects that the league average score is greater than 150 per grade. So in other words, just for clarity, H naught's going to be, the average is actually 150. The alternative is what we want. We suspect that the alternative is greater than 150. Okay, the scores in the sample have a mean of 156 and the standard deviation of 30. So what is our T here? It's going to be T equal to our 156 compared to what we assume was 150, divided by our standard deviation of 30, divided that by, of course, the square root of our sample size, which is 36 games. And based upon that, you're going to do the calculations. You're going to get 1.2. So T, you would fill in, is 1.2. Guys, hopefully you're getting the idea of this. Again, if you think about it, what is a T-statistic? It's comparing how far your sample data is from what you're assuming should be the real result. And you divide by the standard deviation. Don't forget that you take your sample standard deviation and divide it by the square root of sample size to get that particular standard deviation. And that concludes this video.